on this computer. All right, good morning. It is April 15th. Today I wanted to finish up um, notebook number 2, that intro to Jupyter Notebook and Python. And then I've got a presentation on bivariate analysis, which is where you start to leak into that whole experimental design thing. And then I got some stuff I want to show you on Excel, and then I'm gonna try and give you like the last 2 hours of the day to just develop a pretty plain Jane spreadsheet for me to get going on that project I talked about, where the United States and different um, factors, variables that pertain to each state. Okay, so if you would please bring up Jupyter Notebook and bring up and navigate to that notebook number 2. Hopefully you did save it on your drive. Yeah, you wouldn't be able to use it from Canvas. And I'll go ahead and I apologize. Well, this is going to be a long morning if I don't get rid of this congestion.
I woke up with it too. You're not alone.
Good grief. Let's see. I wanted to share Chrome. Well, that's that one tab. So mark all present. Woohoo! Now, if I go to, I didn't share just that tab. I think I shared all of. Look at all those tabs I have open. I've ran into some people that they'll keep open every tab they open during the day just in case they want to go back to it, and each one has like one letter, next to it, and I don't know how, but this is more tabs than I normally ever have open. But I had a busy morning putting this presentation together. Let's see, my notebook, there it is. Bam. That's still sharing. Look pretty much where we left off last time. Okay, so like I said, my buddy Mike's got a great sense of humor. He will occasionally use the Captain Obvious guy from what commercial is Captain Obvious in? Like a kayak or some travel site. Anybody remember Captain Obvious commercials on TV? What do you guys work? What do you work all day?
No, we stream.
Ah, commercials. That is so 2015.
Exactly.
Anyway, he's on a commercial for one of the travel sites. I can't remember which one. I could Google it, but it's off topic. Anyway, Mike likes to use Captain Obvious occasionally. So here we go in this code cell here. A few things I want to point out. You can read the comments along with me. Variables are just that. They store a value and they can be reassigned. The most recent assignment statement is what reflects the value being held in that variable. Couple of points we want to make here. The equal sign assigns the value of 8.41 to sales tax amount. When we get into logic and we're checking the value, it's 2 equal signs for those of you that have coded before. So I will occasionally, some languages, they just use the equal sign. Then it just figures it out that you're testing or you're assigning, but that's a Pythonism. So if I accidentally am doing a test of a value and I just put 1 equal sign, you're welcome to point that out to me. So yeah, sales tax amount equals 8.41, assigns the value on the right-hand side of the equal sign to the variable on the left. Sales tax amount, that's a good variable name. I'm telling you, when you guys get into working with projects and actually doing work, take the time to use good variable names. Because there's another thing I want to show you here. Like if you're in Jupyter Notebook, and a lot of development environments do a similar thing. But if you're in Jupyter Notebook, let me hit enter on the end of that line to get a new line. And I'm going to start typing, say I wanted to do something else to sales tax amount. I've assigned it 8.41, but anyway, if you start typing in um, a statement like that in Python, do what I did. Go to the end of hashtag good name, hit enter, and type in SALE, and then hit tab. And in about 1-2 seconds, you get a pick list um, that it guesses. It's like kind of like Google predictive typing. So you don't necessarily have to type in that full variable name. So you don't have to type in sales underscore tax underscore amount every time. It'll bring up that pick list. So that should help help you not get, because it's so easy to be lazy and use X, Y, and Z and I and ref or whatever little 3-letter words, but it makes it harder to understand later. So I'll just get rid of that. I just wanted to show you that. Hit tab, and it'll give you that little pick list. Tax, that's a bad name. X, horrible. Don't I mean, unless you're just really just you have no intention of ever using the code, use a meaningful variable name. And then the next thing, the sale total, is an example of assigning the result of a mathematical operation into a variable. And the order of operations, as far as which, if it does multiplication, division, it does parentheses first, then multiplication, division, addition, subtraction. Exponentiation is in there somewhere. Anyway, if you're doing a lot of math in Python, you're probably going to want to memorize that closely. I use parentheses rather than relying on the order of operations when I'm doing a mathematical statement in a programming language. Parentheses are free, and they give you the confidence as a programmer that it's that you're doing these group things like tax divided by 100. So I would recommend you use parentheses because they don't hurt anything. And if you type now, check this out. I commented out print sales tax amount. Let me uncomment that. And I'm going to go up to cell, current output clear. This is I want to call it a Jupyter notebookism. I don't think it's inherent to Python, but just be aware. If you just type in the name, go ahead and hit run and run that cell. And you see you've got sales tax amount, which is 8.41, and then you've got the sale total, which is the 4.33. If you just type the variable name, it will spit it'll spit the value of that variable out. But watch, if I comment out the print statement, comment hashtag until I don't hashtag much. Now let me clear the output there. And if I run it again, you only get one value. See that? If what it's doing is if you don't use the print and which tells Python to go down to the next line, print, and then go down to the next line, go down to the next line, it just sends it to output and it overwrites the previous thing. So if by chance you're used to doing that, just be aware of it. I never do that. I always use the print statement. For one thing, it's much more obvious when you look at it that you're printing the output, but just something to be aware of. Okay, so now we get into data types. This is a lot like Excel, where you have you can choose the type of that column. It can be date or numeric, floating point, text, those sorts of things. Python has 4 or 5 data types that we'll be going over, that are that behave differently. So you want to know what type you're dealing with. Um, can't contain a dollar, space, or comma. In our remember, in our convention, we're going to use meaningful name underscore meaningful name. That convention, so we all understand each other's code. So a numeric data type um, can be either integer or float. Floating point is, has a decimal point. Integer is just that. And there are times when it'll error if you send the wrong data type, the wrong type of number. So that brings up another topic I believe we will get into in more detail, but you need to realize that in most programming languages for this, and I am speaking to those of you that are not programmers, and I apologize to those that are. But conventionally, in most programming languages, you you tell the program in advance of using a variable that you have this variable. You have to declare it. It's called, and you basically, it's just a statement where you say like, what we sales tax amount is going to be floating point. So you'd say sales tax amount float, and it just establishes that variable before you go and use it in any sort of math or print statement or anything like that. But Python that's called static typing. And then once you create that variable of type float, it's type float. That's it. You can't turn it into an integer in your code. But Python is the opposite extreme. You don't have to declare your variable. It guesses based on your assignment statement what uh, what the data type is. So when it guesses, it may or may not be what you wanted it to be. You may have wanted it to be a string of characters that looks like 4.09. You know what I mean? You may not have wanted it to be a floating point. So you can convert a variable, and you can convert it permanently by just doing a statement, or you can, if you're passing it to something that is depending on a certain type of variable, you can adjust the data type in that statement. So we'll, like I said, as we go through here, I'm just introducing the topic. Don't expect that to make perfect sense to you yet. But that's the difference between static typing and dynamic typing. And in Python, for somebody who learned like C or Java or one of these conventional languages, um, it's alarming to have these variables guessing. Oh, I think I'll be a string. Oh, I think I'll be an integer. It's but that's the way Python works. So that's numeric data types, and then we come on down here, and then we have string data type. That is just a one or more characters together in a set. So yeah, Arthur, and you can use single or double quotes um, to enclose a string. Just pick one, and go with it. So run that cell, and and you can see we're in the print statement. We can send as many variables. You just separate them with a comma as you want. And then in this next block goes into a little bit more detail on mathematical operators, but it is like you would expect, and the syntax is very much what you would expect. The exceptions might be star star, because there's no way to put x and then put a little 2 above it. You know what I mean? So x star star 2 would be x squared. And then percent sign. Every once in a while, when you're doing when you're coding, you'll need to know the remainder of a division. Like if something is evenly divisible by another number, the remainder will be 0. That mod character, modulo, is the percent sign. It comes in handy. And then, yeah, use parentheses to show the order of operations because it defaults to, parentheses first. But then to show readers you did it on purpose. That's the thing. And the reader could be yourself. You might be doing yourself a favor to use parentheses. Um, and this is kind of what I was talking about. This next line, floating point and integer division is result as a float. Integer division, it'll be um, return as an integer. How would you do a square root with it? That's a good question. Anybody want to come off mic? If all you had was the star to, like, do x squared, how would you do the square root of x? Anyone? Well, good. I'm not the only mathematically challenged person in the room. It's 1 over it's the reciprocal. So you don't have to do some kind of function of square root. It's just 1 divided by the equals it. Yep. Okay. So when you're mixing types, just be careful, and you'll get to know this these rules as you use Python. But this is what I was telling you. You can convert this int open parentheses if by chance I declared a variable like we did sales tax amount. We ran that up there, and it's 8.41. So let me go down here and do a click there, insert, cell below, code. So let's do print and then SA tab, sales tax amount. Oh, it even does literal strings. How about that? Print sales tax amount, print. Run. Okay, so we're seeing that's floating point, right? So if I wanted to temporarily or just use the integer version of sales tax amount, tab, I could convert it to integer by using a function, which is a function is a piece of code that you send a value and it returns something back to you. It's kind of like a conversion function, but you're expecting a value back. So actually what I'm printing, got to have 2 parens because we had 2 on the left, so we got to have 2 on the right. So when I'm printing the return of what int is returning after I pass it sales tax amount, it's going to hand me back the integer portion of sales tax amount without converting it. We'll run that. See, it truncated the decimal places off, but it didn't convert it. So if I do it again, tab sales tax amount, and I print it again, you'll see it's 8.41. 8 is the converted line, and then you see I didn't change the value of sales tax amount. So that's an important thing for you to understand as you get going with programming.
Are those functions predefined, or is that something you also have to assign, like you do with the variable?
There is a world of functions out there that are standard with the library. Pretty much any sort of, once you kind of get going with programming, and anything you can think of that you need to do is out there in a function. Now, I will say that the very base Python language that we've pulled up here has a surprising number of things that are not in it for the sake of memory management. That kernel that is doing the translating for us, turning this Python into output, the more Python code, these cool analytical libraries I keep talking about, and there are standard libraries that do more mundane things that come as a base part of the language, but they come with the language, but they're not necessarily being used in your code. You have to import them. Math is one. There's a library called Math. There's one called that lets you do slightly more advanced mathematical stuff. I think that's where the statistical, like basic statistics stuff is. There's another one called System that allows you to interact with the operating system, and it'll vary based on whichever version down, which distribution of Python you're using. It knows you're on a Mac, or it knows you're on a Linux box or a PC, and it knows how to talk to the operating system to get things like system time and whatnot, off of the computer. So that those libraries, and it's just part of the learning process. You gotta learn what's in the standard language, and when it's not, you Google it and you go, oh, I got to import the math library or whatever. I mean, it's just part of the progression. So yeah, there are hundreds of built-in functions to do cool things for you, like like converting a data amount. Actually, I think technically, print is a function that returns an output for you, and you're passing in a parameter, and what it returns goes to output as opposed to just storing it in a variable somewhere. I think technically, but I don't want to get ahead of myself because we got to talk about object-oriented programming, and we got to talk about methods versus functions, and it starts to get really a little bit complicated. So, all right, let's see what we're doing in this next. That was just a demonstration, Giselle. You don't need to worry about that unless you want to see it work. Okay, what should, I haven't run it and I cleared it for you guys. Hopefully you haven't run this. What are you guys thinking? 12 minus, take 1 minute. I'm going to do the same thing on the back of an envelope, which is where all significant math occurs, on the back of an envelope. And I'm going to guess. And then I'm going to call one of you. I'm calling on one of you. I know everybody's really intimidated now. Don't call on me. He's mean. I don't like that. Okay, and the order of operations, I believe, was up above in that markdown cell right up here. Okay, so the first thing. Okay. I will admit, doing math in public is very scary for me. So, Gabe, what'd you get?
I got -24, but that's incorrect.
Oh, did you run it? Did you test it? I have not tested my guess yet. Let me see who else I can pick on here. Damon.
Hey, I got -18. Yeah.
Okay. So we've got -24, -18, How
I
about you?
also got negative 24. So
Well,
I
okay.
second that.
How about you, Priyanka? What'd you guess?
I'm really bad at math. I'm still trying.
I'm sorry?
I said I'm really bad in math. I'm still trying.
Oh, okay. I did it as quickly and as accurate as I could. I guessed 6. I got 6. But I could be completely wrong. So I'm gonna run it here. Like I said, I flying without a net. 4. There you go. Oh no, hang on.
I think that's for the.
That's the
Yeah.
let's comment that out. That print statement overran that. That's why I never, ever, never leave out the print statement. It's just anyway. So that cell now, if I go cell current output clear. Now if I run it, it's 12. Yeah, I guess I blew the ×2 at the end because I'm trying to think. It's 3 squared times 2, so that part's 12, right? And then
No, three to the power of 2 is 9, right?
3 is 9 times 2 is 18. There you go. So there you go. As opposed to putting it in parentheses would probably make it, I did not draw parentheses around what I knew to be the order of operations. But I think you could change this by goofing with the parentheses and making it over.
My answer is 12 as well, Don.
Oh, you did get 12?
Yes.
Oh, okay. Yeah. All right. It is 12. So let me so that's what I said. I never ever but you can always just print that. Just put it in parentheses, and it's not a we're doing math here, right? So what do we got? 907. Man, I worry about not having enough material for you guys. Sometimes I worry about going too slow or too fast. So as you can tell, I just worry a lot. Let me I want to do a good job for you. Sometimes I think I'm going too
So
slow. Sometimes I think I'm going too fast.
not to be the one to argue this,
Sure.
but technically 12 would be incorrect because subtraction comes last according to the math rule.
Well, it's and again, that math rule, that is my buddy Dr. Ellis stating that out. He might not have been super clear. Addition and subtraction, I want to say are co-equal, and it's what order you see them, you know what I mean? What order they occur in the equation. I believe
Okay.
that's to be super
That's
specific.
the only reason I got 24, and I'm sure that was everybody else who got 24.
Well, there you go. So it seems like they're co-equal. So it does them from left to right as you see them in the equation.
Gotcha.
Okay. So here we got, our print statements now.
And Don, just to double check, I tried the same equation in Excel, and there as well I got the answer as 12.
You got what?
I tried this in Excel as well, and there the answer is 12 too.
Okay.
How did you do it in Excel? Did you just copy and paste this or what?
Yes. I put an equal to symbol before 12, and then where we had 3 square times like 3 to the power of 2, there I directly gave it as 9. So it's 12 minus 6 multiplied by 3 plus 9 multiplied by 2.
Oh, gotcha. And I got 12.
Okay. And then you notice integer division there in that print. 16 divided by 4 puts out a floating point by default. But I want to see, again, this is that, the data typing sort of thing. You would think if I assigned temp int equals 16 divided by 4. You would think temp int would be an integer, right? But it sticks that 40 on there. I don't know if that, I'm going to move on. I don't know if that's a formatting thing or I think we can, you can check the type of something without modifying it. I think it might be that where it returns the type of whatever variable you send it, I think. Yes, it does. So look at that. 16 divided by 4 gives you a floating point. So I'm telling you, with Python, man, you cannot count unless you're, you really working with it constantly. You can't count on this dynamic data typing to do what you're expecting. So you virtually always, once you're getting, like, if you get input from the user, which is the next notebook we'll go into next week, it's you almost always want to convert it. Just force a conversion to the type that you want it to use. So just get used to that. And then this was a homework assignment. This, you were supposed to figure out what break-even quantity was. So, but I've already done it and it's there. So this is an example of just a mathematical operation. It's just a simple business equation. You have fixed costs and variable costs, and then whatever you sell it for, and that's the equation for it. So we'll run that, and then you're seeing the 40 is your break-even quantity that comes out. But then next to the output line, it's got fixed costs because we're not using the print statement. And like I said, I see there's just never in my dorking around with Python and helping students and whatnot, I've just never used that. So I think as we go through these notebooks, you'll see that less and less. But that's there you go. I'm trying to remember why we have divided by.
That turns the result into an integer, right?
Yeah.
Is that what okay? It automatically does the type conversion for you.
Yeah.
Now, did you just know that yourself, or did integer division gives the
That's
result
all.
as an integer? You read the screen. Hey, way to go! There you go. So that is that's a way to force that type conversion as you're doing the math. And there's just a bunch of Pythonisms like that. If you're working in a language, you start to learn the conventions and assumptions and everything of the language. And there you go. Okay, so concatenation is gluing two strings together. So go ahead and run that cell. You can, inside of the print statement, the plus for string variables, it's not mathematical plus. It's stick them together, kind of like you would think. So it's kind of context sensitive. And then if you add two strings together, it concatenates them. It doesn't do some crazy, thing where it tries to add letters to each other. So that's how you create full sentence, is by concatenating first name and last name. And you'll notice there's no space in between Arthur and King of the Britons because you didn't concat a space, but we could fix that by concatenating a space inside of there, I believe. Yeah. So, and you can string as many of those concatenations as you want. Well, sometimes when you're making nice output, in a Jupyter notebook for a manager or something, these print formatting things will become more important than they will to you just as an analyst running numbers. Yeah, code inside a cell can be run independently. Yeah, so you can jump into a notebook and run these cells in whatever order you want, but depending on how much importance was placed on the order of those cells, you got to go top down. So yeah, just remember that. There may be times when you open a notebook and try to do something in one of the bottom cells, but the library that you were counting on is imported previously, and you'll go to do it and go and you got to go back up and rerun that import statement, or none of the cells will understand what you're doing. Okay, I think we're getting to the bottom of this. I want to finish this notebook out and go on break. And here's another homework exercise. I've got exercise. Once we get a sufficient amount of Python going, I want to actually have you guys take some time aside and work on some programming challenges. Okay. I'm reading the bad practice, numeric literal in a calculation. Oh yeah, okay. What he's talking about is when you're writing a program, and you're doing some calculations based on some values. This numeric literal, there are string literals, which are like Arthur King of the Britons, and there are numeric literals, which are a number. It's usually better practice to declare that 0.0885 as a variable somewhere one time, so that if whatever that meant, whatever that was, if that's like the bonus rate for your salespeople or something like that, if that does change, you only have to change it one place in your program, is what he's getting at there. So sticking a numeric literal within a program makes you have to go look for it and potentially change it in different places. That's kind of what he's getting at, and it doesn't add any meaning. What is 0.0885? Why is it in that calculation? Why is it important? If you don't have a really good comment, you won't, the next guy maybe won't understand what that is. So that's where in the next block he's showing you assigning that as the sales tax rate is better practice, and then then you use those variables with their assigned values for all your subsequent programming. So yeah, here's a programming exercise, but I got lots of those, so I won't. You won't have any shortage of practice. But I do have to stop talking during these 4-hour sessions so that you can use that time for practicing. Okay, I didn't go over this last time, guys. When you're closing out of a Jupyter notebook, remember file, close, and halt shuts down the kernel that's running in the background. It's on your taskbar down there, but it shuts down the kernel for that tab, for that notebook. And Chrome by default goes ahead and closes that tab. And then you need to remember to go back to your Explorer tab and quit. And it generally does not close the tab for you. But you have quit, so it's elegantly shutting down Python, but you still got to close the tab out. And I always had this this markdown cheat sheet that I keep talking about. Gives you what you're trying to do in the right hand column, and the character control characters you have to type in, like a star bold star to make a character, to make stuff bold. Remember, this is in your markdown cells. So that is in Canvas. It's under your, go back to home, go down to your Python programming module, it's called in Canvas. And it's down here, down here, down here. Markdown cheat sheet. So if you're, if you're working on a project, that may be something you want to keep open in a tab, so that you don't have to Google it all the time like I do. Okay, yap. All right, I wanted to finish that notebook, and we'll go on break till 9:35, and we'll pick up with some thoughts on bivariate statistics, bivariate analysis, looking at two variables. See you guys back at 9:35. I had real trouble with a university learning management system, Blackboard. They have a video chat tool, basically the same functionality as Zoom. And I had real trouble as soon as everybody turned on their camera for 10, 12 people. We had audio dropouts in frames, so there was something going on with Blackboard Collaborate Ultra. So I switched over to Zoom during that last data analysis apprenticeship, and there's no going back. So, okay, I'm sharing my screen, right?
Yeah, you are.
So you can see bivariate analysis. Okay. So yeah, I wanted to touch on this, but this is kind of the last I intend. I apologize. My son had to come home from work today. Is anybody else having like allergies? Like I'm having trouble clearing my throat, and I think it might be a high pollen count day. I mean, Gabe has her respirator on so that she's not breathing in all that pollen. So I don't blame you. It's rough out there. Go ahead, Gabe.
I'm in an office.
Yeah, it's terrible. I can't wait till this is over. But anyway, bivariate analysis. And this is a brief overview of some of the most common ways of looking at two different variables and combinations of those variables. Won't go into any depth. If this sort of thing, if knowledge of this area is something that you need, there's no end of supply of detailed instruction out there. Like I said, I would recommend a college class in it. But this, just mentioning these topics, it's hard to draw a bright line between bivariate analysis and the whole, like I said, inferential statistics, where you're inferring statistical significance of a sample to the wider population, and some level of confidence that your change, your predictor variable, it's called, will get going though. And I'm gonna blast through this, and then I want to go into Excel a little bit and get you started on that state project. And then I want you to take some time and just work in Excel, work on your state spreadsheet, cutting and pasting, doing some charting, whatever, however far you can get. But then I want you to turn that in later today, just so that I know you're making progress. The business question thing, I quit an hour early, and there were some folks that didn't post their response. So I beg you, use the time that we have set aside for the class, and I will do absolutely everything I can to not go outside that. But please don't let work suck you back in just because I turned off the camera. Okay, use that time for this class material. Okay, so bivariate analysis. It's looking at two variables, and that's what we're looking at, the relationship between them. This classically, you use the x-axis, the horizontal axis, to be your predictor. That is what is changing, that we are now looking for how it affected a change in the y variable going up and down. That independent, in classic research, it's the independent variable versus the dependent variable. In other, there's some different terms for them: explanatory versus outcome. They're all basically synonymous. You're looking at two variables. One, you're changing, and you expect the other one to be an effect. So there is some expectation of cause and effect, although you have to be careful when you're looking at two variables to draw conclusions about cause and effect or causality. But anyway, that's what classically the x variable is independent, and the y variable depends on the x-axis. So you would use, like, looking at age and height, you would use age along the x-axis because age affects your height. Your height doesn't. You know what I mean. Height doesn't affect your age. Otherwise, I'd be young forever because I'm only 5'8", man. So that's what those two variable types are. So here's some examples that include types of variables, because we have two major categories of variables, right? We have categorical, male, female, smoker, non-smoker, or even that those are kind of binary. Then you have, education level is, never finished high school graduate, some college. There are official Department of Education categories for education level. And then, it's unlimited. It could be placebo group or received treatment. It could be, any sort of category like that. What department you're in an organization. So classically, what you'll see for when X is categorical, like you got it or you didn't get it, and then you look for a change in whatever the medicine is supposed to help: cholesterol, blood pressure, or your self-reported perception of happiness, if it's one of the many happy pills on the market. So your X category is your predictor. Got the medicine, didn't get the medicine, smoked, didn't smoke, those sorts of things. And typically when you visualize that, and I wanted to talk about the mathematical test and what kind of chart you would use for each of these three categories. You would use a side-by-side box plot that would show you between the two categories the difference in, the box plot shows you the median, and it shows you how spread out the data is. So that would give you some idea. If you had a placebo and a drug group and the box plots looked exactly the same, visually you would assume that it had no effect, right? Because the stats came out looking exactly the same. And the mathematical statistical tests, I am not going to go into. This, like I said, this material is all over the place. If you're doing this sort of thing, you're going to need lots more instruction than you're getting from this apprenticeship. So, but t-test, z-test uses the z value, which is the distance from the mean, the mean in standard deviations. ANOVA's, there's a analysis of variance, and there are different scenarios where these mathematical tests are more accurate, more effective, more informative. So you have to, they involve, they can involve the size of the sample, and they can involve the distribution of the population may not be normal. So you can't necessarily depend on one test fitting all. It's not a one size fits all for these mathematical tests, and that's the kind of stuff that you learn in a no kidding stats class, and you'll go through the painful mathematics of figuring them all out. All we'll do in subsequent weeks is look at how Excel gives you that number and what it means. Okay, so that's when you have a categorical variable and your result is a continuous value. So you're really your experiment would be phrased in terms of a null hypothesis that is, the medication has no effect. You might have heard of everybody's heard of a hypothesis, but I didn't realize what a null hypothesis was until I started my doctorate and had to learn these research methodologies. But the null hypothesis is basically nothing to see here. Our experiment between our two variables, nothing to see, no change, no impact. Your alternative hypothesis is that something significant happened. And that's up to you to design the experiment. You would have to be a blood pressure clinician to say that, we're looking for a change in 10 points of systolic blood pressure, or as you'd have to be somebody that knows about cholesterol research to know how much of a decrease in the mean cholesterol we're looking for to call it a successful clinical trial. So the measures in those hypotheses are going to change, going to vary, based on the expertise. But that's the basic premise of a null hypothesis and an alternative hypothesis. And then you run the numbers, and based on your statistical tests, if you had enough data and it wasn't too all over the map, as far as the results, wasn't too widely distributed, didn't have too much variance, then you could draw statistically significant conclusions with a given level of confidence, that you can accept the alternative hypothesis that something was effective. But each of these three categories of experiments and bivariate analysis you'll approach them differently based on what you're trying to figure out. So the next one, X is categorical and Y is categorical. So for our example, you're either a smoker or a non-smoker on the x-axis, and we're predicting our hypothesis is that there's some relation between whether or not that person who was a smoker ever got cancer. Really simplistic. And the visualization is a side-by-side bar chart, and I'll show you that here in a sec, where you would have smoker and non-smoker, and then cancer yes and no between the smokers and non-smokers. And the test for that is called the chi-squared. I got a slide on that in just a sec. And then the other categorical, or the other that's classic. This is two continuous or numerical variables, like anything, height and weight or whatever. X is what you would be testing to predict changes in Y. Like you'd look at income levels, and I chose, just as an example, I don't have the data behind this, but how does income level and hours of TV correlate? How does that relate? I don't know. I could, maybe I'm a sociologist, and I've noticed anecdotally that people with low income don't watch TV because they don't have time. Or maybe I've noticed the opposite. Maybe I've noticed that people that make a lot of money have a lot of leisure time, so they watch way too much television. I don't know. I would develop a hypothesis, gather the data, and then look at the correlation. And this is the classic Pearson's coefficient R and R squared that you see a scatter plot. And I've got an example here. I did some of this in Excel, some of it in PowerPoint. But anyway, those are the three categories I wanted to kind of bring to your attention. But I suppose, what do we not have here? That X is numerical and Y is categorical, I guess would be the fourth permutation of those two that I don't know if that's even feasible. But anyway, these are the three that I saw as I was, kind of brushing up on this stuff. Okay, so t-test and ANOVA, these are definitions. Oh, these slides are up there, by the way. It's bivariate statistics are on Canvas. There's some links in the speaker notes. This describes the t-test, and it's an example of the basic when to use this. T-test is for two populations, and ANOVA is multiple. So ANOVA is not really necessarily bivariate, but anyway, like I said, these mathematical tests require you to understand and like estimate the population distribution and the population mean. Sometimes you have to estimate that. Sometimes you know it from just regular research. So there's it's not trivial if you need to decide which one of these and back up your choice. You're going to need to be educated in this area. But that's t-test and ANOVA. And then the chi-squared test that we talked about, that's looking at the two categories and whether those categorical variables and categorical results have some relation. And then good old Pearson's coefficient, that looks at the average distance from a line of best. When you look at the scatter plot, it actually measures and averages the distance of each dot above and below that line of correlation. And then I'll show you in Excel, there's a way to get that number and a way to get the equation of the line. So if you wanted to plug in an X value, you could predict what your Y would be based on the data that you do have. But again, guys, if this is in your future, you got to take a stats class and then use it. That's the other thing. You can take the class, but then it just fades into the background. So this is the first one I was talking about. You've got categories. This chart does not match my data, so I apologize for any confusion. But you've got the category before and after, these blue and red. If you're looking for something like they have in this example, they've broken down they're multiple categories. There's before and after and age category. So it's not just X and Y, just two simple categories. So kind of look at each one of these pairs of box plots would be two categories, before and after. And then on the left, say that's, that could be, say, cholesterol. Okay. So before, your cholesterol was 148 or so. After the medicine, your cholesterol is 142. So it would be up to the scientists, say, to determine if a 6-point drop in cholesterol was medically, clinically effective, for that medication. So that's one way of visualizing a difference between two categorical variables and against a numeric Y variable that varies from 0 to whatever the scale would be. So that's a visualization for the first kind of comparison. And then we have the two categorical variables. This is where we're we're saying that the x-axis, which is only has two values on it, yes or no of smoking, is a predictor visually. If we can look at the impact of whether or not you got cancer, and I guess this would be looking at at past historical data of people that have already passed on. Would make the most sense. But anyway, just for two categories of smoker and yes and no, you have a whether or not they got cancer or not, and you can tell visually, as you would expect. But not every experiment comes out the way you thought it might, just by intuition. This puts a finer point on it, though. If they smoked, about a third of them got cancer, and if they didn't smoke, maybe a 20th of them got cancer. So you can start doing the math to draw conclusions against two categorical variables like that. But the chi-squared number that would associate a high or low correlation between these two categories. Okay. And then your classic, I want to say I had that in Excel for some reason. I'm trying to remember why I would have wanted to show it in Excel, just what the data looked like. But anyway, I'm drumming on. Okay, so here is your typical scatter plot. You've got some predictor variable along the bottom here. And I do have this in Excel, so I wanted to pop over there real quick. You've got some predictor variable here to the right, and it is predicting this change in the y variable. Now, this is a good chance to talk about scale. This chart has all this dead white space over here. I should have reformatted it to go from maybe 150 to 250,000, or I'm sorry, 1.5 million to 2.5 million. What this is, though, is crime statistics in violent crimes in Arkansas based on population growth for a given number of years that I cut and pasted into Excel. So before I pop over into Excel and talk about Excel and our next project, any questions on this or the first hour of what we covered in Python? I forgot to ask for questions on the Python. Questions or comments? I don't see in your business questions you guys using this sort of thing all that much. Am I wrong?
We're using some Python and Domo for averaging, so like a mean function of some of the Likert scores we talked about before. But
Okay.
other than that, that's about our extent use of Python right now.
Okay. Well, I'm going to cover Python gradually throughout the course, and I encourage you to muck with it. I've got a book of sample problems that go from easy to difficult to give you something to chew on. But yeah, I hope you'll come away from here feeling like you know how a computer program works. That's the goal. I don't think no one's going to be an expert in any of this stuff after such a short time. So are any of you using metrics like this in either your off-the-shelf analytics tools or custom drawn in Excel, looking at any sort of graphs quite like this, or these measures, these measures of relationship like chi-squared and Wilcoxon single variable and R-squared and all that?
I'm pretty sure my organization is, but I've yet to dive into it to really see, but I know they use a ton of different charts and things like that. So
yeah, was that Damon? Or no, it was Thomas.
Thomas.
Sorry.
Yeah,
I saw Damon come off mute. Yes, you're both. Thomas, you're at Heart Hospital. Damon, you're at Blue Cross Blue Shield for everybody's information that hasn't memorized that. And they're both very similar domains. They're both going to be looking at, healthcare analytics and trends that all involve clinical data and patient data and patient demographics and whatnot. So yeah, I'm sure within your organization, somebody is using this stuff, but just to, classically or normally, none of you will be responsible for setting up that hypothesis of an experiment. You might be asked to analyze the data and present charts like this, and maybe even present, what the number is, like this R squared. I'll show you how Excel does that. It's really straightforward. So, okay, well, we'll leave it there. I'm gonna give you I'm gonna quit talking here in about 15 minutes to give you the last couple hours of the day to work with functions and formulas. Like I showed you just you can do mathematical formulas. You can do the exact same thing as we're doing in Python, those sorts of operations. You can do it in Excel. And the best way to do it is just start playing with stuff, whether you're, slicing and dicing strings of characters or cutting the first 3 characters off of something, or you're doing a ratio of, last quarter 3 sales to quarter 4 sales, and you're doing a percentage of what the increase was. The best way to get in there is just play with it. And that's where I'm leading right now, is that state project. So I'm going to stop sharing this one. But notice here, the y equals mx plus b, good old fashioned slope of a line, formula of a line. That's what you would plug a value into and then solve for y to predict what a change in this horizontal axis, predict what change it would have in the y axis. And then your R squared value gives you a measure of just how confident you are in that change, a measure of correlation. 0.8 is pretty close. 0.8 is pretty well correlated. That's pretty good. It goes from -1 to 1. Okay, 1 being perfect. So that's pretty good. Let's see here. Stop share on that and share first one here. Okay. I'm gonna go first to here. I was dorking around with Excel since 5 o'clock this morning. I said I can usually get it to do what I need it to do, but man, I'm clumsy with it. So practice makes perfect, just like we talked about with Python. I'm gonna let you guys use your Bibles and the sample sheets that I gave you, and this. I'll get you started on this project, this U.S. state data project. So violent crimes in Arkansas. I got this off the web somewhere, and it gives you. Everybody can see my spread, my screen, right? I downloaded this, off the state website somewhere, and you'll notice immediately all these multiple lines up here. Line 1 through 9 is overhead stuff, about the data, and that is going to screw up. That's going to screw up your charts and whatnot, when you're doing analysis. So that's where I was talking about you earlier in the course. When you're working with a spreadsheet and you're going to be, charting or doing anything, neck it down, edit it till that it's as small and pure as possible, so that you're only dealing with the data in a given worksheet that you really care about for that worksheet. Because when you start dealing with 70, 80, 500 columns of information, it's just cluttered, and you don't really need that for that that analysis. So yeah, when you'll see stuff like this where you got header data, you just got to delete it. So what I did was I went and if you look down here, we got the population of Arkansas. This is your real header row. So really starting with line 10 is where you got something useful, and then you've got your data. I went in and I cut and pasted population and violent crime into this sheet. All I did was click on population, and then I went down to, I don't know, 20, 30 years and held shift and clicked again. And that it will select everything in that range, just like Word or any other tool from Microsoft. And then I hit Control C, and you see it starts this little dot racetrack, this hypnotic little dots going around in a circle. That shows you the active selection, that's been copied. So I copied that, and I went and I hit the plus sign to start a new sheet, and I pasted that into a new worksheet, so that all I have now is a nice clean population and violent crimes, right? So then I click in the data, and I said insert recommended charts, and I picked an XY. It had a few to choose from, see, but I didn't think a bar chart was necessarily, and I wanted to show correlation in a scatter plot. So, so I chose the top recommended chart, a scatter plot, and said, okay, that's it. That's all. Everything else is magic, right? So I want to point out some things that I would need to go back in and fix, which I don't really understand, but like I said, I don't use Excel constantly. But it named the chart violent crimes, which is really just my y-axis. It didn't name my y-axis violent crimes and my x-axis population. So this is population going from nothing left to right. Now it also doesn't know to use to use 150 to 300,000 would be a whole lot better chart, right? So you have to go in and edit the chart to change the range of the scale on both. You can do it on the X and the Y axis. But I ran out of time this morning trying to figure out how to get the X and the Y axis to be labeled violent crimes and population. And the title should be, population's effect on violent crime in Arkansas from 1960 to whatever, right? So anyway, this is a scatter plot, and you can see visually that it's pretty well correlated, but what's making it look a little too vertical is the issue of scale. It's kind of crammed in together. So that's where, as an analyst and a data storyteller, you've got to go in and decide how the chart should look, and there are things you should do, things you should not do. There's a link in your classroom, how to spot a bad chart. That's an interesting TED talk that talks about how a bad graph can really misrepresent what's going on in the data, and scale is one of the biggest ones. Either not putting a scale, or using like they'll show on the news, oh, the Dow Jones Industrial Average took a giant beating today, and they'll show a scale that's like from 26,500 to 27,500 or whatever. And oh yeah, we had a big, in that scale, it's a bad plunge. But if you look at 0 to 27.5, it's a little blip. You know what I mean? So there's lots of things about charting. And like I said, we've got a section on visualization and perception and whatnot. And I can't wait to have Bill Shander come in and speak to the group. So here we go, a scatter plot. It looks, as population goes up, crime goes up, duh, you'd think. But the way I added the metrics, where you right click on any data point in a scatter plot, and then there's you get your menu, and add trend line will add both the line of best fit, and hang on, there's a dialog box that's being covered by my cameras. But then you can also display R squared and display the equation. And that's mathematically helpful, not so much the equation, but the R squared value is your metric, of mathematically, is there a correlation between population and violent crime? And you would think, duh, but some places have expanded their population and violent crime has gone down. So it not every intuitive thought is proven to be true when you use the data. But anything 0.5 is starting to be correlated. 0 is absolutely no correlation. It's just a random blob of dots. 1 would be perfect. As X increases by a given unit of measure, Y increases by a given unit of measure, and that holds true no matter what happens. That would be a value of 1. And whether you square R or not, and it's the same number, you know what I mean? It'll never be more than 1. But whether you square it or not, there's some rules for whether you take R or R squared. So anyway, yeah, that's a scatter plot, and that's the metric next to it. And like I said, when you're working with these charts, they can be automagic, but you need to play with them to get comfortable with adjusting axes and whatnot. So that's what I wanted to show you about that one, was kind of transforming. That was a little bit of data transformation. You can cut and paste a limited amount of data from one worksheet into another worksheet to clean things up. So let me close that out. I'm pretty sure this don't save. Okay. Yeah, screen hash stop sharing. Yeah. I want to check real quick and see if that's in the classroom. I thought it was.
That Excel sheet.
Yeah. Arkansas crime data. Yeah. Arkansas crime data 1960 to 2014. So there's lots of columns to play with there. Like I said, right out of the box, there's like 9 lines up top that you're going to want to delete. But then you can start to correlate things, and you can play with that if you like. There's also a couple of links here. Data cleaning with Excel, part 1 and part 2. Let me make sure I've got that. Loading a new tab. Yes. Those are presentations I think are worth your time. If you're not an Excel, data cleaner. Let's see here. Okay, so I went online. Well, I'm trying to remember where I started here. Okay, let me share. Thanks for sharing, Dawn. Let me share Dawn's U.S. States project. I have not loaded this up, but I wanted to provide you something to start with. Okay. I Googled, hang on. There we go. To start my project, my own version of what you guys are going to be doing, I went out to Google and I Googled Excel spreadsheet of U.S. states. And some analyst out there got tired of having to create this. You're seeing the states, right? In caps and in upper lowercase, and then the two letters. Got tired of creating this over and over and over again. So they posted it online. They created it once, posted it online, stuck it in their hip pocket so they always have it. So there you go. I got started there. That's the raw data. So I didn't, and that's a CSV file that I read in to Excel. And actually in Windows, I've already got a comma separated values data file or is already associated with Excel. So I double clicked on it, brought it up as Excel, but it's still a CSV. Even though you're looking at it in Excel, it is still, if you say file save, it thinks it's a CSV. So I went in and saved it as an Excel workbook. So that's what I'm dealing with now, is a CSV that I read in, but now I've saved it as a meaningful Excel workbook. Okay, so that's the raw data from the CSV where I say U.S. states raw, because I didn't want to dork with it. I wanted to keep that version of what I read in. But then I created a tab. I did, new tab, where I can start adding columns, because that's what I'm wanting you guys to start doing. So I started Googling, like, U.S. list of U.S. states by population, and there are data sets out there from government agencies and stuff on Wikipedia. It's kind of hard to cut and paste from a Wikipedia table that has more data than you want, because it gets kind of ugly. But there's no end of things about a United States. How much they're spending on certain programs. How many miles of interstate highway they have, how many cars per capita there are. There's just no end of things about a United States. How much they spend on healthcare. The number of people over age 65. No end of things that you can use using your creativity. I'm not going to tell you what columns to put in your project file, but you just start thinking about, questions. How do these things relate to each other, and give us some information about a state? How does the age correlate to, how many cars are owned, or whatever? Anything. It doesn't really matter. This is just, just for exercise sake. So I went out and I found the state's population from the Census Bureau. So let me stop sharing that project. Actually, I should share my whole screen. Share screen. So I went out and found the state population, which again, is everybody seeing state population from Census Department?
Yeah.
Yes. Okay. Thanks. I can't. I've downsized the cameras, so somebody come off mic and let me know if I ask for confirmation. This is the unedited file. See, I got a tab here called unedited, and a tab called processed. Again, I don't want to goof with the original data, just in case I need to get to something that I don't want to mess up the original data set. It's just the way my brain works. So unedited, this thing has some summary data, kind of like what you might do with a pivot table, which we will get to at some point. But you don't want that, right? With graphs, it'll confuse Excel. So we're doing the 50 United States, right? So I had to go through and make sure that there wasn't something goofy in here, like District of Columbia, or any other territory like Guam or Puerto Rico. Sure, there's Puerto Rico down there. So and then you've got this block of annotation down at the bottom. So when you get a spreadsheet like this, there will often be garbage that you don't want, and that's the whole data cleansing process that you hear people talking about. So what I wanted was the total. I wanted population, and I wanted it just for the states. So I started doing some cutting and pasting, and this is as of July 1st, 2019. So you just got to realize your constraint. So I started cutting and pasting just the states and the population figure. And I went down here and selected all of that and copied it, Control C, and then I created a new tab, a new worksheet called Process Data. And notice I made sure everything was sorted in alphabetical order, just like our project table. You don't want to paste a column in the wrong order, or it'll be in error. So I went in here and I got rid of Puerto Rico. You can see I deleted that. I deleted that row, Puerto Rico, by highlighting it, so now I have a clean, semi goofy looking to me, data set of the 50 states starting in row 2, which is really weird. And I'm trying to drag and figure out if you go to A1, because I did not paste special, like Priyanka was talking about last week, which I'm going to show you here in just a second. A1 still had value in it, but the line, the size of the cell is tiny. It's been shrank down, and I couldn't quite figure out how to get that going. So anyway, I cut and pasted these 2 columns over here into my my project file. That's what I did for my bar chart. Over here, U.S. states, all data. So I've got it. Let me make sure I do this because I was practicing this morning. I want to select all of column A and all of column B. Can't do the 2 merge cell. That's what happened. Okay. So column, I'm clicking on the value, not the whole column, because something's going on in row 1 that is goofing with me. It's a merged value, which is complex and screwing things up. So I'm just selecting the 2 corners, right? Alabama down to in the lower right
Don,
corner.
question.
Ma'am. Yes, ma'am.
Why is there a period in the cell Alabama just before A? You see it in the function tab?
When I click A. I wonder if that's a helping me. I don't know. Dirty data. Thank you for pointing that out, Priyanka. You run into goofiness like this, but let me get rid of that. And actually, I don't need the state again, right? I don't need that because I got the state name in my project file. So what I did was I just I selected Alabama's population down here, went down to Wyoming, which is crazy how few people there are in Wyoming. Control C, copied that, and then I wanted to show what Priyanka was talking about. So I'm going to have a column here that I want to be 2019 population, right? So let's call it that, 2019 population. Okay, so starting with Alabama, now if I right click, what happened? Go back over here.
Don, we can use the shortcut Control Alt V.
Hang on. Okay, I'm sorry. Say that again, Priyanka.
The shortcut for Pay Special is Control plus Alt plus V.
Okay. I'm a right click guy, but we definitely need to post. I need to post an Excel keyboard shortcut for those of you that prefer keyboard shortcuts. Okay, so I copied just the population, 50 rows of population data in alphabetical order, right? So I right click on that cell. Now here's our paste options. And this is what Priyanka brought up last week is there's paste special, which will bring up a dialog box that brings up a lot of options that you will very likely use frequently when you are moving data around like this and doing this whole data wrangling, data munging, data cleansing type of exercise. So if you paste all, that'll bring in, if it was derived from a formula, it pastes the formula, not the data itself. If it had formatting, like every other line was a red, white, red, yellow, green, or something weird like that, it'll paste all of that. So all you really want is values. And you can see over here, if they had drawn borders, how some people want to make a spreadsheet nice and pretty, right? if if that spreadsheet you're copying from had implemented borders and any of that sort of thing, they will come over with it. So yeah, paste special values only is often to me what you want to do. So you say okay, and bam, there's your population from Alabama and down. Okay, so I'm gonna save this Don's U.S. States project. I'm gonna save this, and I'm gonna close it. And I'll close that one. And oh, this is intro to charts. This is chapter 20's accompanying workbook, and I'd highly recommend you use class time to go through chapter 20 and look at these charts. If there are data cleansing questions, if you have any questions about that, the links that I put in there are worth your time. If you're going to be cutting and pasting and assembling data sets, like I'm talking about, with any sort of frequency, you're probably going to want to get familiar with, watch some expert go through some data cleansing things, sorting and filtering, the things you might think about, so that you gain fluency. But then I want to allot, class time without being too extreme. I want you guys to work on this stuff during class time. So for the rest of the 2 hours we have remaining, what I would like you to do is take this. I'm going to add a file, create, not an assignment, create a file, create files, choose files, Don's project. Where am I at here? On my hard drive, I have Don's U.S. States project. So this will get you started so that you don't have to munge your own indent at one level. You don't have to munge your own starting point. So, and that's going to be up under Worksheet Fundamentals. Okay, so, and it is published. So somebody come off mute and confirm for me. You might have to hit like refresh or something. Confirm for me that you're seeing Don's U.S. States project.
Yes, I can see it.
Okay, thank you, Brittany. Okay, so to get started, and you don't have to use population. I just put that in there to kind of, kickstart the conversation of what I'm looking for you to do. Find some figures about each U.S. state. And, like I said, you guys that are in healthcare, it could be, the percentage of the population that's covered by insurance, or it could be age, or obesity levels, or obesity rates, or anything like that. Start finding, find yourself, 3, 4, 5 columns out there. The one I wondered about was like miles of roadway versus cars. They don't necessarily correlate. Wyoming maybe off the charts. You could use, population versus size and derive the density. But for now, for this part of the project, I want to do this as we talked about in the data analytics cycle. So be thinking of what your question is and make a note of it. You don't need to include that in your spreadsheet or anything. But be thinking of what you're trying to answer. And those questions are going to be really, really, really specific. They're going to be like, how does age and number of automobiles relate? among the 50 U.S. states? That's a kind of question you can answer in a very focused, academic exercise like this. So be thinking of, questions like I keep mentioning that you would like to answer about the 50 states and how data about them relates. If you can think of a categorical variable, which could be yes or no, one of the original 13 colonies. There may be some relation between the original 13 colonies and something else. If you can think of a categorical variable that you can then assign, whether or not it was part of the Confederacy, if it's a right to work state or not. We don't want to get too deeply into politics, but you could look at whether it's a red or blue state in the last election. So if you can think of categorical variables as well as good old fashioned numeric variables like either raw numbers or percentages would work. Start assembling some columns, and this will get you into Excel and get you, if you're not free, if you don't use Excel frequently, you'll learn by trial by fire when you paste something and it doesn't look like you want it to look, or you select something and it kind of goofs up. You'll have to troubleshoot, and like I said, you've got no end of support material in your Excel Bible and the spreadsheet, the worksheets that came with it, workbooks that come with it, and Google. And I posted a few links here that are really good tutorials that walk you through stuff methodically. So that may be worth your time by itself, depending on who you like to listen to and whatnot on YouTube or LinkedIn Learning or whatever. So I'm going to, and I'm tightrope and walking without a net here. I'm gonna go down to data analysis with Excel, to that module, and I'm going to create an assignment. Assignment name is draft states workbook. So all I'm looking for is your columns, and I'll be able to go, oh, I see what you're looking at. Name your columns something meaningful, so that I can see where you're going with it. And turn that in here at, before you call it a day. But please take the remainder of the day to explore what we've been talking about and fill in the gaps for yourself. Some of you, this is old hat. Some of you, it's kind of new. So as adult learners, I got to rely on you guys to kind of adjust for yourself based on your own needs. So create assignment, add item. Draft states workbook, and I will publish that. Let's edit it. Didn't ask me anything about it. Like, I'm not going to, it's not a graded assignment, but I might have to do some homework. But you should be able to upload your file to it. If for whatever reason, like I said, I'm flying by the seat of my pants here. If for whatever reason you cannot upload a file to, somebody click on that and see if there's a file upload area. Does it look like you'll be able to upload a file? I would expect to be able to enter the due date and the points and all of that. And for whatever reason, Canvas isn't being particularly intuitive.
It
Doesn't look like you can. Just says no content.
Well, okay. Well, that's my homework. So if I can't get it figured out, I'll put an announcement in the classroom to email it to me, but I'm going to get it figured out. I'm going to get it figured out. Right?
So
Yes.
for today, you just want what our categories are that we're going to be comparing.
Sure. And if you're like bam, 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 and you can think of your categories, real quick, and you can, and you're a whiz bang, you're welcome to add a chart or two that either summarizes the data. You could do descriptive statistics, the relationship. You could do bivariate analysis of two columns. So yeah, I want you to use this as a reason to go play with Excel. But yeah, all I'm really looking for today are the columns. So just and pick 4, 5, 6, whatever interests you, and we'll and then kind of save this thing in versions, and try and save your raw data in either in tabs or in separate files, because we're gonna use this data in Python and see if we can't write a program that does the munging of your raw data and add it to the Python version of a worksheet, which is a data frame. So save your raw data, whether it's a CSV file or an XLS spreadsheet. Create a folder and save that raw data somewhere, because it'll be useful later. That's all I'm looking for. So yeah, give me a little bit of time, and I'll have this I'll have something that you can you can upload called Draft States Workbook down at the and it'll be in Worksheet Fundamentals. It will be, and I will indent it. It'll be here under Worksheet Fundamentals. Look for something called Draft States Workbook here in a little while. So for right now, I'm going to delete that so that it doesn't confuse you. Remove. Okay. So when you see it, it'll be ready for you, and I'll figure it out. I'll have something you can upload to sitting there. Any questions? Was that clear as mud? Everybody doing okay? Easy peasy, right? Okay. Well, the best way to get a hold of me is to text me. Does anybody not have my cell phone in an email or somewhere? Let me, I'll throw it up in the chat window somehow. Chat. If we're, if you're ever, running late in the morning, got a question, the best way to get my attention is to text me. If you call me, I get so many robocalls I may not answer. So, bam. So there's my cell. You're welcome to call anytime except, at night. If you need something, let me know. Or if you need clarification, if you've got some time to wait for an answer and you want me to write it out, email's fine. Or you're welcome to give me a buzz, and we can chat about things. All right, guys, I'm going to get to work figuring out how to. I created an assignment. It didn't look like an assignment, so we'll see.
I think if you create a discussion, you can upload files to discussion.
Yeah, but an assignment is private. You know what I mean? I could do a discussion, and I may have to. I'm sure the student preview mode will work, and I'll be able to figure this out. Hopefully, I won't upload a page that says, what was it going to be? Draft States Workbook. Hopefully it won't be something that says, I couldn't figure it out. Email it to me. Okay, guys, I'll let you get to work. Holler at me if you need me, and we'll get in touch one way or the other. Otherwise, I will see you all Tuesday morning, 08:30.
Okay. Bye.
Okay.
all.
Have a good weekend.
See everybody.
Bye, guys.
Thanks, Tom.